So, hi everyone, my name is Oleg. I'm working in a company called Doist, which is fully remote company behind Doist and Twist. And yeah, nice to see you all in Vilnius in Lithuania. And for me, Lithuania is a very interesting country. Like, first of all, the big fans of basketball, which I really like. And then they have meal called Zeppelin AI, which I really hope not something under Apache. And yeah, it has AI in the end, so it's double everything. Regarding AI, as far as I know, Lithuania is one of the most oldest European language, right? And at that age, they were so smart that invented a suffix called AI. So now they have 1,000 words with AI suffix, like bar AI, anti-AI, a lot of them. It's really cool, by the way. And I even have a small tip for startup. If you want to name your project, make it on Lithuanian, so you will have AI by default. It's really great. Yeah, and at that century they also knew what does mean AI, because AI by itself, like a word, means oh dear. So it's probably they knew that it's something terrible and very hard. So yeah, and AI, it's almost about data processing, and we are all together here because we are processing data. And each day we are trying to simplify our data processing way of how we're dealing with data. But data could be kind of complex. It could have some different issues. And here I outline main of them. So basically, data could be complex. Sometimes it's really hard to build the systems which can perform hard, big data structures. Also, data could grow fast, and you can have a really big amount of data. Also, data could change because everything in our real world is changed, and data could or should be processed as quickly as possible. So, yeah, and today I can propose you to dive into the root and to try to see why we have these issues, dive to the core of these issues. And for this, I would like to propose you to solve a very simple task. Let's try to read a log files and try to find some substring in each log record. It's easy task. You can just read log file and then just check if some string in this log record. But here's the problem. You can have a very big amount of data, which it will be very hard to process. You can spend hours or days for this. Yeah, and we already made a very efficient algorithm, which if we consider that substring and row record is very small, the complexity of this algorithm will be O(n), which already is very good. We can't make better. We can't read file faster. So how we can solve this? And my proposal following, let's try to split big file into smaller ones, just by chunks. And let's try to use, for example, threading or multiprocessing, which we have in Python. And yeah, the solution will be also quite simple. Just put all log files passes to queue and then just read everything in parallel. But image, if you decided to calculate some analytics here, in this case you need some global object and you need some locking system to prevent some bad stuff which could happen with threading. So it's already a bit more complex task. Then you decided to commit some other data to database, and you need another thread in current thread with another queue, and it's growing kind of complexity growing kind of fast. And raise your hand who want to change something here. No much people, yeah, because the complexity of this kind of approach will grow exponentially, and it's really hard to deal with this kind of code. Also, if you visit Stack Overflow, you can see a lot of weird issues. Yeah, and it's really hard to manage them. Also, if some error happen in between, you will have very bad situation because you need to repeat your code at the beginning, and you will have some half state in your database. If you have picture like this, it's also a problem. You can't scale more because you used everything what your machine provided you. So here the full list of problems which we have. First of all, we have global objects. Then it's not support fault tolerance. It's not scalable. It's really hard to build a complex system, and it's really hard to maintain these complex systems. And yeah, we have another problem. Data could be complex. Data structure sometimes is really hard to process in simple way. So how we can solve this? So solution is, let's try to use queues. So basically, it's kind of popular approach right now, especially on the website, on the web, where we can process some jobs on background. And right now we have a lot of different solutions, like Celery, Redis, Kafka, SQS, choose whatever you want. But basically, this is the global service which can just help you to communicate with different processes. It's like standalone queue service. And I like to explain this approach based on Redis because it has a very simple data structure. So basically, image we have a process which called client or producer, which just push log files to your Redis queue. Then we have another process which just read Redis queue and try to process files one by one. If we run worker process multiple times, we will have a parallel and what more important, distribute system, because Redis communicate with processes using network. And also we will have a full fault tolerance, because if something happened there, we can just return back our job to the queue. So from design side, it will look like this. We just push files to the Redis and then read them using workers. If you want to calculate some analytics here, you need a database, pick whatever you want. But yeah, it's still networking. So this approach has some problems. And first of all, it's a performance problem, because you introduce network here and it's, let's say, a bit slower than threading or multiprocessing. Then it's really hard to understand full image of your workers. Because worker, it could be we can compare a worker to a microservice. The problem with microservice, it's not easy to build. You need to write documentation, set up everything, and for workers, it's really easy to create a new one because it's just a matter of one decorator. So you can generate hundreds of thousands of them, and then you will have a very complex graph with the cycles, which is really hard to manage and work with. So then we have another problem, which is hard to make a change. Because image, you have old worker and create a new one, we change the data structure. And if you deploy this in a second, you can have in queue all data, and then newly deployed worker will fail because he tries to process this all data. So this is a very bad situation, because then in the queue you will have old and new data in the same time. It's really hard to filter this. And then we have a last very bad situation when worker could make a side effects or change global state. Image we have functions like this. It's actually a worker or Celery task. We decided to calculate some analytics here. And then we're trying to save this analytics to database and call another worker. So if something happened in between, we will have situation when we commit to database, call another worker, but then something failed and worker trying to repeat this task because fault tolerance, which we know. And he will repeat this task multiple times, so we will try to commit data to database multiple times and call another worker also multiple times, which call data duplication, and it's really hard to solve. And we can't solve this situation even with transactions. So here is the list of queues problems. So basically we have a performance problem. It's really hard to understand full picture of how data is changed. It's really hard to apply new changes, and we have a side effects. So here next issue related to data. So data could change, and it's really important how we can manage this change. So how to solve this? So basically we have data pipelines today. So data pipelines, it's a way to connect your workers in the right way, so to prevent some issues which we have with the workers and queues. And first I want to tell you, like, the data pipelines, it's not ETL. So basically you can use data pipelines for make ETL, but it's not only like one way how to use data pipelines. Like basically ETL, it means extract, transform, and load. And it's something like, I don't know, like maybe MVC on the web. It's just a concept. And data pipelines, let's say it's just UWSGI. So you can compare this stuff. Here is the same situation. Like data pipelines by itself, it's a way to connect your workers in a serial way. So output of one worker will be input for another. But yeah, this is what Wikipedia said, but I like to say that next element, like next worker, will be called only in the end of the current one. Like, and we will have this kind of graph, like it's like a tree, and basically don't have any cycles. So it's really easy to understand what's going next, and we can very easily understand how data moving through our system. So it allows you to build very like a good image of data processing graph. So if we back to our problem with the queue, when we change a global state and make side effects, if we try to implement data pipelines using queues, you can see that we like move worker call to the end of this function. And it's important also that in this case we don't call any workers inside other functions. So the idea here, so if something happened in between, we don't call worker, so we don't make any data duplications. But we still have some problems with database because we will try to duplicate data inside database, which is, for now, it's a bit hard to solve using data pipelines. So right now we have following tools which will help you to build data pipelines. It's Airflow and Luigi, but again, it's just a tools which could help you to like connect your workers in the right way to prevent some issues. So in the end, like we have following benefits and problems for data pipelines. Like we have a very good picture of how our data is changed. Then we can easily apply change because we can just create new branch in our tree. It's really simple. It's maybe not very simple in Airflow and Luigi, but it's really simple in terms of data pipelines. But we have still some problems like performance problem and side effects. So how we can solve a side effects problem? And here we have ETL. It's basically like a concept, like pattern, which allows you to extract data or get data from any source you want, then transform this data somehow, and then load this data to some source. This basically means that you can solve like a lot of different tasks. It's not about only about copy data from one place to another. I really don't like when someone says it because using ETL you can solve a very big range of different tasks. So from design side, ETL will look like this. We have a tree with different workers, and on the root step we have a function which extract data from source. It can be like a request, it can be database, file, command line, whatever you want. And then in the middle of this tree, we're trying to process data, to change it somehow, filter, and only on the leaves, on the end like step of our branch, we can commit this data to database or any other global like object state, whatever we want. If we try to implement like ETL based on queues, it will look like this. So we're trying to calculate some analytics. Then in one transaction, we're trying to call our workers. And then like in the worker, we make only one transaction to database. So if something happened in function called load to database, we can repeat this function and everything will be fine. We don't duplicate any data. So but it's kind of hard to implement such like concept based on queues. So that's why like a year ago I started a project called Stairs, and it's a way to implement like queues data pipeline ETL approach in a very simple way to to have like a very efficient way to process data. And like from design side, it looked like this. So basically you have a producer functions which allows you to extract data from any source. Then you push data to pipelines where you have like distributed parallel anyway calculations of your data. You can also push data directly to pipelines if you want. And then in our pipelines, we just call consumers, which then could change a global state and make side effects. So from a code side, it looked like this. We just defined stairs up, then define the producer, which in our case just read a log file, just yields log files, paths. Then we put this file log to pipelines and subscribe to this data some functions. Each function could be a worker or not. This means that it will communicate with another function using queue or any other streaming services. Then we can call like another pipeline, or we can call consumer, which will be just a standalone worker, which can then commit data to database. So a consumer side will look like this. So basically we can have like a simple consumer like this, saved to database. We just insert something to database. If it fails, it will repeat it once again. So, and we have consumer something like consumer iter, which can just generate your data in a separate process. So for example, you can have a neural network in a separate process and just consume data from your data pipelines directly to your neural network. So this is basically like example of how you can use it in a different range of tasks. This pipelines is really easy to run. So you need just one command, pipelines run. It will run one thread, one process, which is really easy to manage and deploy. For example, we can deploy this to AWS Lambda. It's really easy to do, and Stairs allow you to do this by default. And also, you don't need like magic job schedule, which like Airflow and Luigi has. So it's really easy to work with, to start with, and deploy. So you can, like I mentioned before, like you can solve a lot of different tasks using data pipelines and ETL, and you can check out like Stairs example, where I like show how Stairs could help in a different task, like data scraping, teaching neural network, make some analytics, or whatever you want. So, and here like small example of how we are using data pipelines approach inside Todoist. So we have AI called Smart Schedule, and we have a web server based on Go, which then just put jobs events to our data pipeline through Redis queue. And then we just call Stairs consumer and then return back data using PubSub. So this kind of approach allows us to process like thousands of like requests, and it's like quite scalable because you can just call whatever you want, like amount of workers for data pipelines. So like in the end we have like following situation. So if you try to use queues data pipelines TL approach, you will have following benefits. So basically it's a fault tolerance by default. It's a really scalable and distributed system. You will have a very good picture of how your data change. It's really easy to apply new changes, and it helps to prevent side effects. But we still have kind of important problem, which called performance problem, and it's a really hard task because we are using like queues, network, and it's kind of, yeah, if you decided to just process small records of logs, it will be kind of problem. But I want to show you some very interesting example regarding performance. Like image, we have an image which with size like 600 by 600. It's like a lot of data. And let's try to just push this image using a Redis queue. Just push these images to the Redis. And you can see that we can like push 200 images per second, which kind of not very fast, but come on, it's like a big image. But then let's try to just rotate image. And you can see that we can rotate only 500 images per second, which means if you rotate your image more than 2 times, Redis will deliver you more jobs that you can process. So that means if you have a hard CPU calculations or just another request to your database, whatever you want, the Redis or another streaming service will provide you more jobs which you can process. But yeah, again, if you have like a lot of very small items like log records and spend not much CPU calculation, you will have kind of problem, but you can solve this using stuff like this. So you can use Spark, which is also available in Stairs. And right now I experimenting with Apache Error and Python mmap, which we actually release soon in Python 3.8. And like using this approach, I can send between 2 processes inside one machine at about 300,000 messages per second. So if you have a very small items, you can solve this by this approach. So yeah, like, and in the end, I want to say that if we will solve inter-process communication in the right way, we will solve a lot of problems because, yeah, we can just generate very simple thread and process applications, and it will be very easy to communicate between them inside one machine. So yeah, and you can check out Stairs, try to write pull requests, try to use it and send me a link to like your project where you used Stairs. So yeah, thank you very much.